Hi, everybody. Thanks for joining our webinar today. The topic will be motor sizing using ANSYS tools. My name is Chris Cowan, and our presenter will be Stephen Anchong Liu. First, I'd like to take a moment just to tell you about our company, Ozen Engineering. Ozen Engineering is an ANSYS channel partner, and we're a company that's focused entirely on simulation. We use finite element analysis, computational fluid dynamics tools, and we do high frequency electromagnetics. We are an ANSYS elite channel partner, and in the most recent year we were selected as the channel partner of the year for North and South America. As a channel partner, what we do is we sell ANSYS software tools. We provide training to customers so they can learn how to work with the tools effectively. When our customers have problems, they contact us for technical support, and we also provide engineering consulting services in case you have a project that you would like completed for you. We can do that. We can teach you how we did it. We can provide you with the files. So we work with the full suite of ANSYS tools, including 3D design, structures, optics, fluids, electromagnetics, and semiconductor embedded systems and systems in general. Most of those tools work together as a multi-physics solution. This is our Wednesday weekly webinar, either weekly or bi-weekly. The topic today is motor sizing. You can see the topics that are upcoming in the next few weeks and the previous topics that we've done. All of the webinars that we've delivered on these topics are available on our website, ozeninc.com. Under the resources, there's a webinar library there. You can go view the entire content that we have there. And if you'd like to be notified about upcoming webinars, you can subscribe to our newsletter. We send out a newsletter once a month to give updates on what are our upcoming webinars, as well as technical tips. And you can do that by going to ozeninc.com/training. One thing I'd like to tell you is that ANSYS has released a new capability called ANSYS Cloud. It gives, the main thing you want to know is that it offers one-click burst to the cloud. It's native, available within the software, and compatible with ANSYS Mechanical, ANSYS Fluent, and the ANSYS Electronics suite. So if you have problems that exceed your compute capability, you can easily solve those over the cloud using tools managed by ANSYS. And if you're interested in trying it, please contact us. We can get you a free 30-day trial. How do you contact us? Our info is here. You can email info@ozeninc.com. You can call us directly, or you can submit through our website a form through our website. One other thing that I'll add is that we are hiring. We're interested in, if you know or you are a mechanical engineer or an electrical engineer, please contact us. We're also interested in engineers who can work in control systems and programming for embedded systems. So without further ado, I'm going to introduce Anchong Stephen Liu. He is a support engineer with Ozen Engineering. For any customers who've had technical support requests, you've probably spoken with Anchong. He has his bachelor's in electrical engineering from University of California at Santa Barbara, and his expertise is related to high frequency and low frequency electromagnetic tools from ANSYS, including Maxwell, HFSS, SI-Wave, and Simplorer. So I will turn this over to Anchong now. Thank you for your attention.
All right, thank you, Chris, for the introduction. Let me start this by sharing my screen. Okay, thanks everybody for attending today's webinar. Today's topic is motor sizing and magnetic design. So there's a clear global demand for a comprehensive methodology to design efficient, reliable, and optimized electrical machines. So ANSYS is now having the full capability of designing a motor. So the impact we're trying to make from ANSYS tools is to have a fast motor sizing with robust design, possibly automation and customizations on the motors, and performance prediction with alternative drive conditions. So, just before we get into the specific product, I just want to go through some of the application examples and the way how we deal with these situations. So one objective here would be fast motor sizing with robust design. The purpose of this is to estimate the basic design of an electric machine topology, starting from a set of dimensions by making initial design decisions based on hundreds of what-if analysis. So the ANSYS solution in this case would be we start with an ANSYS MExpert as a template-based solution. We'll get into the details of MExpert just in a couple minutes. After using MExpert, creating the template, we will analyze the various drive conditions on selecting machine topology. Then we would use a ANSYS Design Explorer for design of experiment and Six Sigma analysis for the motor. The impact of this workflow on the design would be, the slot opening since the slot opening is a critical design factor, so it will also affect manufacturability, cogging and torque, rippling for brushless PM machine, and every performance aspect for induction machine. Then there's other application examples so this is a Six Sigma analysis. The bottom the bottom image is probability density versus clogging torque parameter. So as the plot goes further towards the right, it starts to defect. So other application example would be automation and customization. To build a automatic process to customize machine design flow to meet market demands for higher efficiency, lower cost machines. The ANSYS tool provides these kind of capability, but it at the same time also involves some human efforts in order to create a workflow like this. So the ANSYS solution is still, as always, we use an MExpert to automatically generate Maxwell transient FEA model. So then within the Maxwell desktop, we can employ fully automated generalized electrical machine design to perform detailed and accurate predictions of electrical machine efficiency map. So by doing so, we'll have a quick FEA design creation without actually creating a CAD. So if you have there's a lot of motor types available for you to pick in MExpert, so you don't necessarily have to have a CAD actual CAD before you start the simulation. So with this capability, this will also enable designers with analyst quality practices, so that the tool is not only limited to simulation engineers, but also design engineers. So, and lastly, the optimal operation points are automatically calculated for the whole torque and the entire speed range. So this will be the efficiency map displayer. We can take a look at the current, the power factor. total CPU time is about 3 hours on a laptop. Other application examples would be including, performance prediction with alternative drive conditions. This will integrate the drive conditions and estimate the motor performance considering various circuit topologies with their control parameters. So we start with an MExpert, and then based on a selected circuit configuration, ANSYS MExpert can also automatically generate the external circuit that's gonna drive the motor. So either it's one phase, three phase. So we can always you can always build an external circuit around the motor. The impact of the design impact of this example would be, selecting the appropriate circuit configuration with optimal control parameters, considering as feedback the machine's performance. Also performing robust design, optimizing the entire electric drive for, as a circuit plus control plus motion kind of analysis. As we can see, there's a filter, the pulse width modulator, voltage feed in, and then we can see the PWM phase voltage as well as the motor phase. That's 10 amperes per division. So this is just the general presentation. So the benefits of ANSYS motor solutions would be firstly, there will be fast motor sizing with robust design, meaning that there's hundreds of what-if analysis you can do in a matter of seconds. There's also other benefits would be, alternative drive conditions, automation, and customization, which is what I've been mentioning all along during the presentation. This is the capability in the software, but as I said, a lot of human efforts will also be acquired. The coordinations between engineers and the software vendor needs to work on this to create a automation and customization workflow within the company. Lastly, there's more than 16 template-based topologies, so including generic routing machine template, slot editor that's user-defined, winding editor, and also distributed parametric analysis and HPC for the robust design. So that's kind of an add-on. HPC is so usually for simulation sites like this, usually motors would take a very long time to simulate. So ANSYS we also have the capability to incorporate with HPC, high performance computing capability, to fasten your simulation process. So we've been talking about MExpert. So let's just take a look at what really MExpert is. So it used to be a separate product within ANSYS CPU electronic business units portfolio. Now it is kind of an add-on tool built in Maxwell. So MExpert is an analytical tool, very powerful and fast, dedicated to the purpose of design of rotating electrical machines. It is suitable to be used as first step in an electrical machine design workflow, providing users with the following, which is a very fast solutions, a complete set of design information, includes no load, full load, and short circuit parameters, different types of driving circuit techniques, a wide set of machine types, and last but not least, the possibility to create both 2D and 3D Maxwell ready-to-run models automatically. So as you can see, this is a generic portfolio of ANSYS motor solution. So we started with the MExpert, then we create the either 2D or 3D model of the motor. Then we do the analysis in Maxwell 2D or 3D. Based on that, we can enable add-on add-on options such as optometrics or design of exploration, which helps you study the the impact that different parameters that's going to give for your motor. Also, after electrical analysis, we can also couple Maxwell with other ANSYS products within other ANSYS portfolio, such as mechanical and CFD, to analyze the thermal stress or acoustic behavior of the motor. And lastly, we can do a system level simulation using Simpler. So the Simpler, now it's called Twin Builder. It's the same thing. It's a circuit system level simulator. You can incorporate your Maxwell motor simulation in the circuit and do a circuit block, do a multi-domain system analysis. As you can see in this block, this green circle thing, that's the Maxwell motor component that's being imported into the Simpler. So overall, in all, ANSYS has a very complete and vertical motor design workflow. Now we can take a look at the MExpert Maxwell comparison examples. So we have MExpert analytical solution on the left and the Maxwell FEA solution on the right. So on the left is a fast motor design that's generated based on the built-in template. That's a 2D cross-sectional view of the motor. So based on that, we can do an analytical solution, and it's also going to be a fast coupling with the system simulation. So you don't necessarily need to use a 3D model for system level simulation. With a 2D model, you can still do so. And based on a 2D model, you can automatically create a 3D model based on that, which will have a higher accuracy and higher fidelity. We can also have a FEA time domain validation based on a 3D model, and then we can do a complete transient to transient co-simulation in Simpler. Available machine types in MExpert, as you can see, there's about a dozen of different machine types from PMSM to BL DC, brushless DC. All different types of generic motor designs are available as template. I'm not sure if this is still the same nowadays when you open MExpert. It used to be as I said, it used to be a separate product in ANSYS. So when you open electronic desktop, the MExpert example, it opens up, and it opens a project where now what it does is, let me check real quick. Right now, what it does is just an add-on available in AEDT, so it won't create any project tree in that sense. Machine data are accessible through the property window or through a double click on machine. So once you create a template, you can manipulate with the parameters on the motor, from number of poles to frictional loss, windage loss, number of poles, rotor position, all that sorts of parameters. So then, depending on the machine type, the control type list can differ too. So there are also different models for the control system, for the control. for the control system. It can either be a DC AC or P pulse width module, while for BLDC there's only DC and CCC. So circuit types describes the possible phase connections and can be Y3, L3, S3, C2, L4, S4. So all different control types are available as well. Stator data are accessible as well. So we can look at from this project tree we can see there's circuit, there's stator, and there's rotor and shaft. So all of these. So for as you can see for the stator, there's different there are different slot types available. You can also do a user-defined slot. Other geometry setups. This would be the dimensions of the slot. For windings, we can manipulate the parameters as well as for phase A, how many turns, blah blah blah. Winding type can be whole coiled, half coiled, or additive. More winding options. Winding properties here, and we can also define the wire size of the winding. On the rotor as well, bunch of parameters to manipulate. Rotor type are also available. Load type and rated conditions. So load type options depend on machine type and circuit connection. So there are, as you can see, there are a couple options you can choose. It can either be constant speed, constant power, constant torque, linear torque, or fan load. So as you can see, under different load type, it gives out the output as follows. For the results, the users can access results by right-clicking on the setup, and we can go to the performance. Results can be checked in tabular form or in a categorical form, as a design sheet or as a XY plot. So yeah, as you can see, the design sheet it gives you steady state parameters, no load magnetic data, and blah blah blah. You can also plot out an induced winding voltage at rated speed. Performance, you can see the performance under full load operation, material consumption, low load operation, etc. After you've done the 2D MExpert, you can right mouse click on the setup and then create a Maxwell design. You can choose between either a 2D or 3D. A 2D, that would be a 2D model of 1/6 of a full model. 3D would be a three-dimensional. So before that, MExpert was just setting up the parameters of the motor, and now it's creating a actual Maxwell design. So once the Maxwell design is created, all these boundary conditions and excitations are already being set up. So as in terms of it is ready to run. So what does it automatically set up? It automatically sets up geometry and material properties, moving setup, boundary conditions, excitations, including the automatic creation of the driving external circuit when needed if you decided to use the external circuit instead of just a voltage or current excitation. Mesh operations is already being set up. Analysis is already being set up. Design settings like symmetry multiplier is already set up, and some default XY plots. So as when you get to this point from in AEDT, the Maxwell model is already optimized, meaning that RMExpert calculates automatically all the possible symmetries and creates the minimum part of the full model required for simulation. So let's take a look at of the RMExpert in AEDT environment. So we insert a Maxwell project. So before that, so right now this has been on over a year. Right now we are in ANSYS 2019 R3 version. So it is a ribbon style software. Uh, there's no RMExpert is no longer considered as a product. Rather, it is an add-on right now. So how do we deal with that is that we go to draw and under user-defined primitives, there's RMExpert, and you can choose different types of uh, types of motor. Uh, so let's randomly choose say band. So now just upon creating that, you can play with uh, the dia gap, the dia yoke, length, a segment angle, fractions, half axle, or infocal. So if we click on OK, it will be just like this. Um, anything beyond that is a little bit different than before. So in the band, we can add a wave coil, and then the rest is the same as what it is on the presentation. Um, so if you're interested in this topic, feel free to to email us at support at Ozen Inc. or info at ozeninc.com. We can share some of the materials with you. Uh, we can go over your questions on ANSYS or model sizings. Uh, and this again, we'll have this webinar posted on our website. Feel free to check out some other topics in the past and in the future. Again, we appreciate your Oz Engineering appreciate your business, and thanks for your attention today. This will be all for today's webinar. Thank you.